um, is Dr. Charlotte Lund Rasmussen, who is from the ARC Center of Excellence for Digital Child based at Curtin. That's what I'll say.
Thank you. Hey. Oh, hi everyone. Nice to meet you. I know nobody here. I've never been at one of these meetings, so I have no idea what to expect, but thank you for having me. Thank you for inviting me to present. The weird accent, I'm Danish. So just to explain if I pronounce something wrong, that's my excuse. And before I begin, it would be nice to just get a feel of the room. Just with a hand raise, have anybody heard of compositional data analysis? All right, two. Great. Oh, amazing. That's way more than usual. All righty. So now, of course, if there's any question, I'll just return back to you guys and expect you to answer them. So what I would like to present today is the use of compositional data analysis within my research field, which is physical behavior research. And I think as a start, anything happening? There you go. I would like to just clarify a bit what I mean with this physical behavior research and compositional data analysis, just for those in the room that doesn't know me. So with physical behavior research, we are interested in physical behaviors where we're referring to behaviors you do in a daily occurrence using your body, being standing, walking, running, sleeping, being sedentary, so basically the physical activity guidelines, everything that's mentioned there is what we're interested in. And these behaviors are often measured using questionnaires or technical measurements such as accelerometer or Fitbit, which you might have heard of. And often we look at these behaviors in terms of how much percentage of a day is used on each behavior, or how much time within a 24-hour period, or a week or a month before. You get the picture. And some of the key questions within this research field include how to obtain valid measurements of these behaviors, how to identify either determinants of how much time people spend on these behaviors, or profiles. And by profiles, I mean a typical day. How does that look like on a population level or an individual level? And then one of the key questions are understanding health effects of the behaviors we do throughout a day. And so what is increasingly being acknowledged within this research field is that the impact on health by increasing time spent in one behavior will depend on how much time is spent on the remaining behaviors. Now, this doesn't sound that great, groundbreaking, but it actually is within our research field because we usually looked at the data just in one behavior in isolation. So just this concept it has taken years, embarrassing enough, for us to acknowledge this. And so, as this group probably already understands, is if we want to increase time spent being active, say, encourage people to run more, well, that time has to be taken away from something, like sleeping. And that is likely to have a very different health effect than if you take that time away from, say, sitting. So this means that data convey relative information. We cannot look at one behavior in isolation. That's a key aspect of this, because that means data is compositional. So you might find within your own research field similar data where it actually doesn't make sense to describe one piece of the data in isolation without looking at the rest. As soon as you have something that requires an understanding of relative information, there is a requirement of using compositional data analysis. Otherwise, you lose key information in it. So that is the principle of compositional data analysis, is to respect this by treating, I'm referring to this data either as physical behavior data or time use data. Sometimes I switch in between just to clarify. And this is done by looking at log ratios. instead of absolute times. So to break that down a bit, I would say that the analysis itself consists of 3 to 4 steps, depending on what you consider a step. But the first step is to define what is your composition. What is the interest of your data? Because you might have a range of behaviors within a day, but you're actually just interested in some of them to explain those. Then that's your composition. I'm making an example here, which basically covers the full day for most people. That will be sleeping and then sitting, some light activities and some high intensity activities. And this is the key step, really, that a lot of researchers within my field stumble on, because we are not used to dealing with log ratios. We're used to looking at absolute values. But the first step would really be to express this composition in terms of log ratios. So meaning instead of looking at higher intensity activities, just looking at that, how much time did you spend running in isolation? The key difference here is that you look at, all right, how much time is spent running relative to sleeping, sitting, and light intensity. So the remaining of the composition. That will be one ILR, it's expressed as. And then you will have, as you see, you split the composition into 3 ILRs or log ratios in this case, because you have a 4-part composition. Let me know to stop or interrupt me if something is confusing or doesn't make sense. And then the third step is to use these log ratios in your analysis. And this is any analysis that you usually do. So that's where people feel a bit more comfortable because they can go back to the neuroregression or ANOVAs or what they're used to. But the key aspect is then to use these ILRs instead of their the absolute value of the number. Now, the main tricky bit here is then you will have values associated with these ILRs, and they don't make sense. Like the value of this log ratio, it's really hard to interpret. So that's why within our research field, we are very visual. We need to see, we're used to seeing, all right, if I run 2 more minutes, then my BMI drops with some value. But instead here, you'll get at, all right, if you increase your log ratio with minus 2.78, then it doesn't make sense. So an important step is, which we are really working hard on still, is to visualize the results. And one of the first attempts to come with a solution for this was to use something called isotemporal substitution, which you might have heard of. It's a principle where it's basically predictions. So it's often illustrated like the figure here. I don't know if I have a pointer somewhere, it doesn't matter. Oh, can you see this one? Yeah, perfect. So let's say MBPA stands for, it's the running time. So high intensity, moderate to vigorous physical activity. And then it's often plotted as if now I am adding minutes to MBPA, going this direction. And then the other direction here, we take minutes away from MBPA. These minutes are often reallocated between behaviors depending on the research question. So this could be an example of, all right, if I give minutes to running, and I take it away from sitting, how does my BMI look? And if I take the minutes away from sleeping, how does the BMI look? And in this example, we will have the BMI, the health score, something like this, on this line, and you will see the impact of replacing time from sleeping or being sedentary or lighter physical activities. So this is one example of how to interpret the results. This was first presented, I think, in 2016. And since then, the field has tried to move away a bit and look more into, all right, well, what's the optimal day? And attempting to illustrate this in these sorts of plots where you will have kind of, can we call it a sweet spot of time use in between. So this, I'll show another detail about this, but just to quickly explain. The principle is about illustrating how much time is spent on each of the behaviors I'm interested in for an optimal health. So, for example, in this study, they found that optimal time use were spending 10.9 hours sleeping, 8.2 hours being sedentary, 3.4 hours being using on time or light physical activity, and then 1.5 hours running, which is a bit ambitious perhaps, but this was the predictions. All right, so this may seem a bit overwhelming, so I thought I'll just present two examples of compositional data analysis used within this research field. And there are a lot of studies. I didn't know what to pick, so I picked one of my own because that was easiest, and I had the size. So this one is assessing determinants of a physical. So in our study, we investigated the relationship between behaviors you do at work and behaviors you do at leisure. And we wanted to assess this among a group of lower socioeconomic position adults because they often have manual work. Whereas I sit all day, so I'm not as fatigued coming home, but we did have a hypothesis that, all right, if you're very active at work, maybe that causes you to spend less time being active in leisure. And so for this, we used technical measurements of physical behaviors among a group of blue-collar workers. And for each of the workers, we looked at average time at work spent being sedentary, standing, walking, and on higher intensity physical behaviors. And that meant for work, we had a composition consisting of 4 parts, being sedentary, standing, light physical activity or higher intensity. And for leisure, we had the same behaviors, but we added sleep. Then we did the magic. We had our composition, and then we expressed these using log ratios and used these log ratios in our linear regression models. And then we could add the fancy word compositional before it, but it's basically a linear regression. And we adjusted for some variables that was relevant. We stratified the results and we found no association among them, indicating that what you do at work doesn't influence what you do in leisure, doing leisure in terms of your physical behaviors. But among women, we found that, all right, if we take 15 minutes from all of the other behaviors at work and add that to walking, that decreased time spent standing during leisure time. And so this might suggest that work, the behaviors performed during work might actually be fatiguing for lower socioeconomic women. And that although we just saw a slight decrease in standing, among this group, they are not really active. So any decrease in any type of activity that might be health promoting can be a risk factor. Yeah, and so based on this study, we could say people doing, making guidelines for being more active, to please consider how active the group is at work. Now, this was a study looking at determinants, physical behaviors. And I thought it would be nice to show an example of where we looked at where it was assessed health effects, physical behaviors. So in this study, again, I was biased. This was my old office buddy, Melker, and I thought he did a great job with this. So I just wanted to share it with you guys. He looked at the relationship between time spent sedentary, walking, and on higher intensity physical activity, and its influence on blood pressure, waist circumferences, and low density lipoprotein. I'm just going to show the the blood pressure results because there were a lot of results here. His composition was a bit more detailed. He didn't look at work versus leisure. He just looked at the entire day, and he classified the group, his behaviors, as being time in bed, being sedentary, standing, moving, which is like this, not really walking, you're just fidgeting a bit, walking, and then high intensity physical activities, and looked at the estimated difference by reallocating time between the behaviors mentioned, sedentary, moving and walking, and high intensity physical activities, and looked how that influenced the blood pressure. He also stratified everything on age groups. And the hypothesis was that, especially among older adults, maybe less is more, that they need lower intensity physical activities to actually see a health improvement compared to younger adults. And just shortly a description of the study population, even split between men and women, both among adults and older adults. We see a higher blood pressure among the older adults, which isn't that surprising. And it was around 1,000 participants in the study. I thought this was a nice way to show an example of that figure I showed earlier, where we have, the estimated difference in systolic blood pressure by reallocating time. So the red dots are the younger adults and the blue dots are the older adults. And what he found was that if we theoretically replace sedentary time with walking, we saw an impact on the systolic blood pressure, especially among older adults. And if we theoretically replace sedentary time with high intensity physical activity, we saw a stronger impact on the blood pressure. So this could be summed up like this: like if among adults we decrease sedentary time and increase walking, we didn't see much impact on the blood pressure, but we did see among older adults that there was a health improvement by increasing walking time. And for both adults and among older adults, it was shown that high intensity physical activity decreased blood pressure. So this is just to show you examples that the essence here is not looking at one behavior in isolation, but keep always looking at, all right, what are we taking the time from? What are we replacing it with? So it's the concept of looking at the data in relative terms. Yeah, this is basically the conclusion. There was an age modification, and we see a health benefit by just simply walking by older adults. One of the things I wanted to mention, I'm about to round up, don't you worry, is the recent developments within this method. So it took, I think the first time compositional data analysis was mentioned within our research field was around 2012. And it's taken years, and it's still not really accepted as a concept, but we are starting to see slowly that the community is accepting this way of analyzing the data more. And with that comes development in the methods available. So now we're starting to see latent class analysis, where we look at these profiles of behaviors instead of just looking at health effects or determinants. We're starting to see more and more using longitudinal studies, which is great because cross-sectional data has its limitations, as we all know. And we're starting to see interventional studies, not only where an intervention is, the effect of an intervention is evaluated using compositional data analysis, but even to the stage where people are trying to do power calculations using this approach. This was the first attempt I showed you, developed by Lund from Adelaide, to illustrate the change in behaviors that influence on medical or on health outcomes. But this is moving more towards this triangle I showed at the start, where we're, instead of looking at reallocating time in between behaviors, a push forward is now, all right, that's great. Now we understand a bit more about changing the time in between behaviors, but we wanted to actually understand what is an optimal day. So that is, I think, the next step. We will see a lot of progress towards. We're starting to see our research have impact. As you know, Australia, we have 24-hour guidelines you might be familiar with. First one was Canadian guidelines that moved away from, instead of just advertising, move more, sit less, actually having recommendations for a 24-hour period day, how we aim to have adults, younger populations, children, older population, spend their entire day for optimal health, which is very encouraging as a researcher when you see you actually, it gets picked up by politics. And we're starting to see that the WHO, which has been pushing back a lot on our on this type of research, is actually starting to understand the concept a bit more and accepting it and talking about a balance between behaviors instead of just focusing on one behavior. And there's actually a request for more research within this from WHO, and especially within the Canadian politician and health authorities that sits with these guidelines, and accepting that there is a paradigm shift in our research right now, and we are a bit of a crossroad about who accepts it and who doesn't. Which leads me to the final, the key challenges for us within my research field that we see, and why this method isn't accepted more. And I think one of the main challenges for us is conducting the analysis. It requires you to learn the analysis to understand the steps of doing log ratios and working with this. And if you've never worked in R before, that's a challenge, because so far it's only in R where there's developed packages to actually conduct this analysis. Then we have a bit of an issue whenever there's a zero, because you can't do a log with a zero. So that actually means you need to manipulate your data or exclude a lot of participants, because we often have participants, let's say you're interested in running and you have a group of cancer patients. Nobody, the zero times been running. So there is some very realistic challenges with understanding or with conducting the analysis. It has a high requirement of the data. And then the last bit, that's still a bit of a challenge, is actually understanding the results. As I kept showing you, there's been heaps of work being done is trying to visualize the data and visualize the results, but it is, still a challenge. And then there's the basic conceptual challenge at looking at all behaviors in a day and not just one behavior in isolation. It's still new. And then we often see that there's this clash between how research is guided and what comes first. Do we look at health authorities and their guidelines, and then we do research to validate those guidelines, or do we push for new research that can promote a different type of guidelines? What we see right now is, especially for adult physical behavior guidelines, are still looking at behaviors in isolation, and then it can feel weird as a researcher to ask a research question that isn't promoted by health authorities. And then there's the risk of not getting published if nobody understands it or it hasn't been seen before. And as a researcher, that's a concern too.